Welcome back to part 2 of permutations and combinations. Some more examples for you. So, there are 28 people in this class. We're drawing names out of a hat for 3 prizes. First place is $500, second place is $250, and third place is $100. So, we're going to put all 28 names in a hat, and we're going to draw out 3 names. Are repeats allowed? And the answer is no. Everybody puts their name in once. Does the order matter? Now, for our free trip to Hawaii, the answer was no, because you win a free trip regardless of when I picked your name. Here, the answer is yes. Why? Because first prize is worth more than second and third prize. So because first prize is worth more, it does matter. You want to be first. You don't want to be third, you want to be first. Order matters. So since there are no repeats and order matters, this is a permutation. Okay? Permutation. So find the ways. So this is going to be 28 people. That's your N. Pick 3. That's your R. So this will be 28P3. And again, I'll put the calculator up here just to show you typing it in. So we're going to clear this off. This is my previous example. And we're going to type 28. Press your permutation key 3. Press enter. 19,656. 19,656 different ways. And this seems very trivial, but when we get into later in this section, you'll understand why we need to do all these counting numbers, okay? Why we need to be able to count all these things. So, a combination lock, like you had on your high school locker, has 40 numbers on the dial, and repeat digits are not allowed. So, repeats are not allowed. That means we can use permutations and combinations. Now, as soon as I know that I have to find N and R. So, N is 40, and R is 3. So if you know N and you know R, the only question is it a combination? Is it a permutation? So are repeats allowed? The answer is no. Why? Because they told us in the problem. Does the order matter? Yes. Because if my combination was 1, 7, 12, and you put it in 7, 1, 12, the locker will not open. So the order that you put the numbers in matters. That makes this what kind of thing? A permutation. This is a permutation. So how do we find the number of combinations? You see, this is a tricky question. Combination locks are permutations. So how do we find the number of combinations possible? This is going to be 40P3. And we're going to type that in to our calculator, and we're going to get 59,280. 59,280. Okay, 59,280. So try these along with me, see if you're getting the same answers I'm getting. We're electing a 4-person board to represent this class of 28 people. So we're picking from 28. That's our N. And we're picking 4 of us. That's our R. Okay? Are repeats allowed? No. John doesn't get to be the president, the vice president, and the treasurer. He gets to be on the board one time. Okay, so no repeats. Does the order matter? If you really want to be on this board, doesn't matter if you get picked first, second, third, or fourth. The answer is no. Order does not matter. So if there are no repeats and order doesn't matter, this is a combination. Okay? So if it's a combination, we know the answer is going to be 28C4. And we type that in, 28C4, and we get 20,475. Okay? So check your answers with mine and see if you can get these same answers. Keep going. We're electing a president, a vice president, a treasurer, and a secretary. So we're electing 4 people from a class of 28. Okay? From a class of 28. We're selecting 4 people. Are repeats allowed? No. Again, you can't have someone be your president and your treasurer. It doesn't work like that. Does the order matter? This time the answer is yes. Why? In the previous problem, you're a board member. You all have equal powers. Because you all have equal powers, doesn't matter which order you get elected. But here, if you really want to be the president and I elect you to be the secretary, you're not going to be happy. So the order does matter. Well, because the order matters, that makes this a permutation. Permutation. Okay? So find the number of ways. This is going to be 28p4. Okay? And I'll just show myself typing this in. I'll set the calculator where we can see everything, right? So here's my NPR button and my NCR button. And so I'll type 28p, right? So the NPR, and I have to press shift on my calculator to get to that, the number 4. And I get 491,400, okay? So 491,400. And so I want to show you now, do you see how those are the same numbers? One's a permutation, one's a combination. Permutations are always much, much, much larger than combinations, okay? So I have one more item that I want to throw at you here before we move on to another topic here, okay? I've got 12 runners competing in a 1,600-meter race at the Olympics. How many ways can they finish? So very just generic problem for you to figure out. So 12 runners competing at the Olympics, how many ways can they finish? So the first question is, are repeats allowed? Well, can Mary come in first and third? And the answer is no. Does the order matter? Well, if you've ever played sports, I guess the question is, do you want to win a gold medal or do you want to win a bronze medal? Well, because obviously everybody wants to win a gold medal, yes, the order does matter. That makes this a permutation. Okay, find the number of ways. So what do we know? We have 12 runners. That's going to be our N. And I didn't tell you this in the problem, but at the Olympics, what do we have? We have gold, we have silver, and we have bronze. Gold, silver, and bronze. So that makes R equal to what? R equals 3. So this is going to be 12p3. And we take our handy dandy pocket brain and we type 12p3 and we get 1,320. So real life application here. How many ways can our runners finish in the Olympics? Now, there is a rare instance. It doesn't come up very often, but there is a thing called permutations with repeats. And we'll stop at my wonderful bold line here. Permutation with duplicate items. And the formula is n factorial over p factorial, q factorial, r factorial, ... Okay? Now what this means, guys, is that your number of things you're selecting from goes on top, and your items with repeats go on the bottom. And the best way to follow this is to sit down and actually do an example. Okay? So if you have one item that repeats, you'll have one item in the denominator. If you have two items that repeats, you'll have two items in the denominator, etc. Okay? So let's take this number 10 here. How many ways can you arrange the letters in engineer? So I go 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters. So N is 8. Now, here's what I noticed. The letter E repeats 3 times. So P is 3, right? That's one of my repeats. And the letter N repeats twice. So Q will be 2. There's my numerator. There's my denominator. This is a permutation because the order of these letters matter, and they matter because in the right order they spell a word. In the wrong order, they're garbage. So this is a permutation with duplication. So here's what our formula will look like. It will be n factorial over p factorial q factorial, which in my case will be 8 factorial over 3 factorial times 2 factorial. Now, a couple of these I'm going to show you how to do by hand. 2 factorial is 2 times 1, which is just 2. 3 factorial, as a reminder, is 3 times 2 times 1. Well, 3 times 2 is 6, and 6 times 1 is still 6, so 6. Now, 8 factorial I don't want to do by hand, so I'll plop my handy-dandy pocket brain up here. And my factorial key on my calculator is right here, and it's literally, I'll write this down for you, is an X with an exclamation point, okay? And so I'm going to type 8 factorial. Should look just like that. 40,320. So that's going to be my numerator, 40,320, which will be 40,320 divided by 12, right? 6 times 2 is 12. So divide that by 12, and I get 3360 ways. Okay, so that's how many ways you can rearrange those 8 letters. Fair enough? Number 11. How many ways can you arrange the letters in Mississippi? So we're going to start with N. N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is 11. And then let's look at our repeats. Okay, my first repeat is going to be the I's. 1, 2, 3, 4. 4 I's. So P will be 4. Q will be my next repeat. The S's. 4 S's. Right? P, Q, and then R. Do I have any other repeats? I sure do. The letter P repeats. Right? There are 2 P's. So P, Q, and then R. Any other repeats? No, I think that's it. So my formula will be 11 factorial over 4 factorial times 4 factorial times 2 factorial. Okay, 11 factorial is going to be a big number. It's 399,168,00. And then 4 factorial is going to be 24. So it'll be 24 times 24 times 2. Okay? And I'm going to go ahead and multiply 24 times 24 times 2. So this is going to be the same number, 399,168,00 divided by 1152. That 1152 is just 24 times 24 times 2. I'll do this division, 399,168,00 divided by 1152, and I get 34,650 ways we can rearrange the letters in the word Mississippi. Okay? Now, the last one is making signals with flags. I've got 2 red flags, 3 green flags, 3 white flags. If we run all 8 flags up the pole, how many different signals can we make? And the idea here, guys, is that if I put a red flag on top, that means danger. If I put a green flag on top, that means all is well. If I put a white flag on top, that means we're out of toilet paper. Okay? And so this is going to be our N. N is 8. And we have 2 red flags, so P will be 2. We have 3 green flags, so Q will be 3. And we have 3 white flags, so R will be 3, right? P, Q, and R. Those are our repeats. So our formula becomes 8 factorial over 2 factorial, 3 factorial, 3 factorial. Okay, well, 8 factorial we did earlier is 40,320. So we can kind of cheat. We can just copy that right off the paper. We did 3 factorial earlier was 6, and 2 factorial was 2. So this is going to be 2 times 6 times 6. So 2 times 6 times 6 is 72. And then we'll just divide these. So 40,320 divided by 72, and I get 560 unique signals that I can make with these 8 flags. So there's our second video on permutations and combinations. If you have any questions, please leave them in the comments, reach out to me, let me know, and I'll be glad to answer them.